Alright, here are the video notes for lesson 2.2 focusing on polynomial functions of higher degree. So we've done quadratics. 2.1 really focused on quadratic. That's like x squared is your highest degree. We're going to focus on all the degrees higher than x squared right now. There's a lot that goes into this, especially in terms of sketching the graphs. And so a lot of this I'd hope to discuss on our Wednesday meeting or again on class on Friday. The first couple things that I want to talk about, or the first one I really want to talk about, is really when we have an even function, generally it looks something like a parabola. When we have an odd function, it's that spaghetti noodle function that we've seen with like x cubed. Okay, that generally stays the same, but the higher n value we get, so like x to the 5th, x to the 7th, x to the 9th, it still keeps that spaghetti shape, but gets a little bit flatter in the middle. And same thing with x to the 4th, x to the 6th, x to the 8th. We have the same kind of parabola shape, but it gets a little flatter down here by 0, 0, around 0, 0. Okay, so just kind of a heads up of like, it's still going to look something similar, but a little different. And the first other thing I want to talk about here is the leading coefficient test. So we know which direction our graph is going to go, kind of our end behavior of our graph here. So if we have an odd function like x to the 3rd, x to the 5th, x to the 7th, and that leading coefficient is positive, so it's like positive x to the 3rd, positive x to the 5th. We see this kind of end behavior where it goes down to the left, up and to the right. If we have, again, odd functions, x to the 3rd, x to the 5th, x to the 7th, but we have a leading coefficient that's negative, so it's negative x to the 5th, negative x to the 7th, we see different end behavior. We see it go up to the left and down to the right. Okay? For even functions, x to the 4th, x to the 6th, x to the 8th, okay, we see that parabola shape, and it's going to go up to the left, up to the right when your leading coefficient is positive, so positive x to the 6th. Okay, here we see both ends going down, so we have down to the left, down to the right, and again that's even functions, x to the 6th, but that's leading coefficient less than 0. So you're thinking like, you'll see something like this with negative x to the 4th, negative x to the 6th, and you'll see that kind of end behavior. Okay, and that's kind of the first step of how are we going to know what these graphs look like. Well, it starts here when you're given something with higher degree. You have to do your leading coefficient test. Okay, so in this first one, my a, if I can grab my pen here, my a is less than 0. I have a negative x here, and I have an odd function. So a rough sketch of my graph without knowing any other things, it's going to look something like this here, where it's going to go up and to the left, down and to the right. And so it's asking me what's happening on the right hand, what's happening on the left hand. Well, like I said, it's going to be kind of doing something like, ooh, that was ugly. It's going to be doing something kind of like this. And so we have up, left, down, right. Okay, and that's honestly, that's all I can really tell, just knowing a is less than 0, and it's an odd function because my highest degree is a 3, which is an odd. More of these in part B, or like part B, yes, right there is, we have the highest degree is an even, so we have an even function, and my a is greater than 0 because that's a positive x to the 4th, so it's going to look something like your standard parabola, something standard. And you have up to the left and up to the right. Okay, and that's just using the leading coefficient test here to say, okay, it's an even, and my highest degree is either, or sorry, my highest degree is either even or odd, and my a is either greater than or less than 0. The thing I want to highlight in this video is the idea of repeated zeros. And so between two consecutive zeros, it must be entirely positive or entirely negative, meaning that we have these different things happening. You are going to get, you can break down a function, and we'll see that in the next slide, where you can see a multiplicity of 1, a multiplicity of 2, or really in the idea is the multiplicity k here, which is going to be kind of like, what is it raised to? If it's odd, it's going to cross the x-axis. If k is even, then the graph is just going to touch the x-axis. Okay, and I wanted to say that before I just start working a problem, but the problem is going to make more sense of that. So here we have our function, and we need to kind of factor this function to figure out where it's going to be equal to 0, and where that multiplicity is going to be when we have it equal to 0. So if we have negative 2x to the fourth plus 2x squared equals 0 here, we can pull out a negative 2x, let's do that, negative 2x squared even, and then that's going to leave us with, in here, x, actually, what is that, x squared minus 1? Let's take a look. That was right, so we gotta see, so that's still equal to 0. And then this x squared minus 1 breaks down, so this becomes negative 2x squared, x minus 1, x plus 1, equaling 0. Now here's what we're talking about with multiplicity. X minus 1, this is to the first power. X plus 1, this is to the first power. Negative 2x squared, that's to the second power. So second power is even multiplicity. First powers here are odd multiplicity. And like we said, or what I was trying to say here, k is odd, it's going to cross the x-axis at the value. Where k is even, it's just going to touch the x-axis. Okay, so we have here negative 2x squared equals 0, which if you solve this is going to just tell me that x equals 0. And since that's coming from a multiplicity of 2, that's just a place where it's just going to touch the x-axis. Okay, the other one here, x minus 1, if I set that equal to 0, that's going to give me x equals 1, and since that's an odd multiplicity, it crosses at x equals 1. It crosses the x-axis. Okay, last one, it would give me x equals negative 1, and again, that's a multiplicity, an odd multiplicity here of 1, and so it's going to cross at that too. Okay, and you can see this is a small little picture of the graph. At negative 1, it crosses through. At 0 here, it just touches. At positive 1, it crosses and goes through. Also, if we want to talk about leading coefficient and even and odd, it's negative, leading coefficient's negative, and it's an even function, so we see the correct end behavior as well. You can see down to the left, down to the right, and then we have this touch cross method, and we can start building our graph based on that. Okay, so you can kind of see what we're doing here. We're going to put a bunch of pieces together to be able to graph these functions by hand to the best of our ability. Got one last problem here, and again, we're going to talk about this one more on Wednesday or in class because there's just going to be questions on it, absolutely, and that's good. And so we'll just do one more example, and this is going to be kind of the example of putting everything together. So leading coefficient test, we have here an a that's greater than 0, and we have an even function, which means my end behavior is going to go up and to the left and up and to the right. Next, we need to find our zeros, and so I'm going to pull out of here an x cubed right away because there's x cubed in both of it. And so I get x cubed, and then what's left behind is 3x minus 4. That's a 1 up here because multiplicity 1. X cubed is a multiplicity of 3. Both odd multiplicities. So we're going to have some crossing happening here. And so with the first one, we are going to have x equals 0 from x cubed, and that's going to cross. And then we're going to have here 3x minus 4, and when I solve that for x, I'm going to end up with x equals 4 over 3, and it's going to cross at that point as well. Okay, I'm not going to worry about a table right now. Okay, I will focus on that table in class or in our meeting because it's just not going to fit here, and we can graph without it as of right now. Moving to the graph, we have just some basic graph that we can do by hand right now. We have to have something over kind of here where I can get to 4/3. Something over here as well. Okay, now we know that there's going to be a crossing point. I'm going to switch colors here. There's going to be a crossing point here at 0, 0. We know there's going to be a crossing point somewhere at 4/3, which 4/3 is a little over 1, so like right here. And then we're kind of guesstimating where the vertex would be down here. Somewhere right in between those two, maybe down here. Okay, and we know the end behavior is going to go up to the left, up to the right, and so we just got to make sure we cross through our crossing points. We're going to have a graph that's something like this. Okay, is it perfect? No, but we're here to sketch, and we're here to try to find zeros and multiplicity and leading coefficients, and so our graphs are not going to be perfect, and the table is going to help it get better when we set up a table. But like I said, in the time I have here, and the explanation of a table gets complicated, so I'm saving that for an in-class discussion or a discussion in our Google meeting on Wednesday. Okay, the last thing is, I was going to mention the homework. The homework looks extremely long. I need to still change these homework problems, so don't worry about this here. They will be posted on Google Classroom. Again, if you wanted to see something before Wednesday, or maybe you can't make the Wednesday meeting and you want to see the table or the another problem like this, just let me know. I'm happy to make an individual video.